All right, day 2 of inverses. So recall, xy is a point on the graph of f of x, then yx is a point on the inverse. The domain of a function f is the range of the inverse of f. And a continuous function will only be invertible, that means having an inverse that's a function, if it's strictly increasing or strictly decreasing. Okay, so those are all things we talked about in the last lesson. All right, so let's see what we can do here. So let f be a continuous function above, selected values from the table. Let g be the inverse of f, so that g of x equals the f inverse. Find the following. So f of 0. So remember, we start with f of 0. That would be 1. Then we do f of 1. Comes out to be -1. So f of 0 is -1. G of -3. So that really means f inverse of -3. So that means that instead of the input of f, it's the output of f. We're looking for the input. Okay, so that would come out to be 4. G of 6, so f inverse of 6. So again, output of f gives us -3. G of -1. So start with g of -1, which is f inverse of -1. So output's -1, input is 1. So then what's g of 1? So again, that's the output of f, gives us 0. All right, next, f inverse of f of -2. So f of -2, we're going this direction. Input of f is -2, output is 3. And then we want f inverse of 3. So that's now the output, brings us back to -2, which should make sense if we're doing f inverse of f. They are canceling each other out, so it should come out to be -2. And then our last one here, it's getting a little crowded up above. F inverse of -3, so output is -3, should be 4. All right, now, given f of x is this rational function, 2x plus 5 over 3x minus 4, find domain and range of the inverse. Well, let's start with, if this is a rational function, our domain of f of x is everywhere except for where the denominator is equal to 0. Oops. X can't be 4/3. Then the range of your rational function, remember, is going to depend on any horizontal asymptotes. And since the degree is equal numerator and denominator, there's a horizontal asymptote of y equals 2/3. So it would be everywhere except 2/3. So now if I'm looking at the inverse, those should switch. So the domain of the inverse will be the range of the original function. So all real numbers except 2/3. And then the range of the inverse should be the same as the domain of the original function. So all real numbers except 4/3. And okay. It's a little throwback to rational functions for you. All right, next one, we've got this function f given to us over the interval -2 to 8. Let f inverse represent the inverse of f. Yes. What is the maximum value of f inverse of x? So that means the maximum y of the inverse. So then we would look for the maximum domain value of f, because then that would end up being the maximum range value for the inverse. So the maximum domain value of f is 8, right? Because the domain of f of x is -2 to 8. And the range of f of x would be -3 to 7. So those switch for the inverse. So the maximum domain value of f is 8. So then that means the maximum value of f inverse would be 8. Find f inverse of 3. So that would mean it's the output on what's being shown here. So where is our output 3? That's where we have an input of 2. Similarly, f inverse of 1, that means we're not putting in 1, we should be getting out 1. And the input would have been 3, so that means the output on the inverse would be 3. And then what's the domain? Well, that would just be the range that we had for f, so -3 to 7. Oops, same as the range of f of x. All right, we got two functions given to us here. G is in the graph, H is in the table. G of H of 6. So H of 6 is 10. Now we do G of 10. So input 10, output -1. So that's, make sure you always go back and label the G of H of 6. Answer that part. All right, G inverse of H of 0. So let's start H of 0. So in the table, H of 0 is 3. Then we do G inverse of 3. So that would be the output of G is 3. What's our input? Would be 4. H inverse of G of 8. So let's start G of 8. Input 8, output 0. What's H inverse of 0? So the output of H is 0, input's -1. And then lastly, G inverse of -1. So that means our output is -1, input is 10. Then we're going to do H inverse of 10. So output is 10, input is 6 on H. There we go.